Welcome back. So let's take a look at the supermarket project. So in section 5.1, we have a list of names: Adam, Alex, Mariah, Martine, and Columbus. So recall that a list, you put it in square brackets, and the entries in the list are separated by commas. And what we're going to do is we're going to cycle through the items in that list. So for every name in names, just print the name. Now, this second element here, that is the name of your list. Okay, in this case, it's called names. But the first element, there can be a little bit of confusion about that. That can be anything. So for example, I'm going to call it X. Okay, so the code is perfectly correct if you do it like this. For every X in names, for every item in that list, okay, do the following: print it out. Okay, but the reason we made this choice, okay, for every name in names is for readability. It sounds more natural. Okay, so names is plural, so it refers to the list, and name with no S at the end is singular, so it refers to the individual name. So that part can cause a lot of confusion. So this here can be absolutely anything, a variable of your choice, and we're just simply choosing the one that's more natural. Likewise, for every fruit in fruits, for every person in persons, and so on. In section 5.2, we're defining a dictionary. So recall the syntax of a dictionary. You give it the name, equal sign, open bracket, and then you go ahead and type out the keys. So we see we have 4 keys: aardvark, ba, carpet, and dad, and we have the values of those keys. So I'll just quickly show you how you would define a dictionary. So you have the dictionary name. Okay, pardon my spelling, but that's not the important thing right now. Space, equal sign, we want those curly brackets. Okay, and I am just going to press enter right now. Okay, I am now ready to begin putting entries in that dictionary. So I press enter and I can begin. So let's say dictionary name. All right, so let's say this is a list of students. So for the first student, it's Fred, and then I do a colon, and maybe I need the Fred's student number, 88888. And then I do the same thing with the next student, Mary, put in the quotes, colon, 9999. So that's how a dictionary works. Okay, so we have a dictionary now called the Webster Dictionary. These are entries in a dictionary. And look at this. For every definition in the Webster Dictionary, just go ahead and print out the definition. So this is a loop. It's going to go to the dictionary called Webster. We're calling the Webster dictionary there, and we're going to iterate through it one by one, and we're going to print out the definition. So again, this word here is absolutely of your choosing, and I just chose what seemed to sound more natural. But like I said, you can put anything at all in there. So I'm putting in there definition. Okay, now let's go on to 5.3. What do we have in 5.3? In 5.3, it looks like we have a list of numbers. Okay, lists are in square brackets, and the name of that list is A, and we're looping through them. So for every number, so just choose any variable you want. So for every number in that list, okay, you want to do the following. You want to see if the number is divisible by 2. Okay, so what you're doing there is you're bringing up what's called the remainder function here. Okay, so you take a number and you divide it by another number, and the remainder, this percentage, okay, that's what the value is going to be. Now, when a number is even, there is no remainder. 4 divided by 2, 4 is even, no remainder. 6 divided by 2, no remainder, and so on. So if a number has no remainder, in other words, it's even, okay, no remainder when divided by 2, just go ahead and print out that number. And we can demonstrate this right now. So let's do a copy and paste, go into your favorite editor here for Python, and we will just simply paste that in, and we'll run it. And we can see that we have a typo in there, but all we want to do is print out a number. So we'll go ahead and do this again, but note first of all that we're using Python 3. So in this case, we need to enclose number in brackets, so we have the correct syntax. And now when we run it, we can see that we've iterated through the list 0 through 13, but we've only printed out the numbers that are divisible by 2 and have no remainders. In other words, these are the numbers, the even numbers in that list. So let's continue. And then in section 4, okay, what we're doing there is we have something called phys count, okay, and we're starting with a value of 0, and then we're going to do a test. Okay, we have a string x, and what we're going to do is we're going to look at all the elements in x and look for, and we're going to iterate through it, and we're looking for all the entries in it called phys. And every time we encounter an incident, we're going to increment the count by 1. So count equals whatever it was before plus 1. And if you recall, this is equivalent, the exact same thing as writing the following. So that takes a little bit of getting used to, but both are correct. But this particular syntax will save you a keystroke. Now, what I want to show you here is we're initializing. We're starting at count equals 0 before we begin this, and then we start incrementing, and then we're done. We are returning that value. In section 5.5, okay, we have a for loop, okay, and we're going through something called Codecademy, and we're going through a string actually, okay, and it works just like a list. So for every letter, we're going to go through this letter by letter, C, O, D, and we're just going to print each letter. So that's something interesting. You can work with a string in the same way that you work with a list, because that's basically a list of letters. And then in the next for loop, we can see here that we have another word, actually a sentence. We've set the word variable to programming is fun. That is a string, okay? And we're going to iterate or cycle through that string. So for every letter, what are we going to do? We're going to test it to see if it's equal to I. And if it's equal to I, we're going to print it. So in other words, we want to see how many times the letter I appears in that string. And I see it 1, 2. I only see it appear 2 times. So you should see the letter 2 appear 2 times. And then in 5.6, we have 3 dictionaries, one for price. Oh no, sorry, we're defining a dictionary called prices. Okay, so banana, 4, apple 2, orange 1.5. So these are the prices of various fruit in a dictionary. In 5.7, we can see that we're listing how many of each do we have. There are 6 bananas. There are no apples. This is what we have in stock in a store. So the interesting thing to notice here is look at the keys. Banana, apple, orange, pear. Banana, apple, orange, pear. They're the same keys, but in the first dictionary, we have prices, and in the second dictionary, we have inventory, how many we have of each. So in 5.8, we're going to work with both those dictionaries, prices and stock, and we're going to first iterate through prices. We're going to print out the item, okay, and we're going to print out the following statement, okay. So remember, %S is a placeholder, and what's going to go in there? We're going to go to the prices dictionary, and prices item will be referring to the item price, 4, 2, 1.5, and so on. In the second, in the next line here, we're printing out the stock. We have another placeholder, and we're going to cycle through our second dictionary and print out how many we have of each. In 5.9, section 5.9, let's take a look at this. Okay, so we're initializing a number to 0. And what we're going to do here, it looks like we're just going to do a calculation. We're going to take every item, okay, and we're going to take its price and multiply it by how many we have in stock. So let's go ahead and do this with our 2 dictionaries. So we'll start off with banana. The price is 4, and we're going to multiply it by 6. 4 times 6 is 24. Likewise with apple and orange and so on down. We're going to take the price and multiply it by the number we have. So price of the item multiplied by how many we have in stock. And then we're going to build up our total. Total equals whatever was before, and then we're going to add the price multiplied by the number we have in stock. And again, if you prefer, you can use the other syntax we have. You can use the incrementer type of operator that we used before. This line here, when you see quote, quote by itself, and I use this quite a bit, so we might as well note that that just prints out a blank screen. Now keep in mind what's happening here. We're looping. We're printing out information, okay? And between those groupings of information, I want a blank line. That's how you insert a blank line in Python. Okay, so go ahead and print out, and we're using -I as an integer value, and there's the total. So when the loop is completed, we will have the total of the price of everything in the inventory, and it will be printed out for us. So if any of this, you have difficulty with any of this, please contact me, and we'll go through it. So in 5.10, we are creating a list, 3 fruit. 5.11, we have our 2 dictionaries, stock and prices. In 5.12, okay, I believe we have 2 left here, 5.12 and 5.13. In 5.12, we're creating a function called compute the food bill. Now notice that I'm starting with a float value. I'm initializing total, and I am going to cycle through food. Okay, so what am I going to do for every item in food? Okay, if it's in stock, meaning we have more than 0 items, then add it to the total. So we're going to start with 0, okay, and then we're going to add it. So what we're doing here is we're going shopping, and we're adding up our food bill, okay? And then at the very end, we are just simply printing it out. So